So students, in the first question, that is question number 4, A is equal to this matrix Aij, which is a 2 by 2 matrix. Now this, students, if it is a new notation for you, I must tell you, this is the compact form of a matrix. In compact form, we basically write the order, so 2 by 2, which gives us an indication that it is a 2 by 2 matrix. So I'll form a 2 by 2 matrix, where the first element is A11 because it belongs to first row, first column. Second is A12, this is A21, and this is A2. I hope you guys already know how to identify the term position. Now, once you identify this, they are saying that the element is 1 when I is not equal to j. When I say I is not equal to j, we're talking about numbers like A12 and A21 because I and j is the row number and the column number. So students, these two elements are 1, which means my matrix A has these elements 0 because A11, A22, their I is equal to j. So it is 0, 0, and this is 1 and 1. This is the matrix A. Once you get matrix A, you're supposed to find A inverse. Now students, I hope you know the trick of finding A inverse of a 2 by 2 matrix. First, to figure out the determinant of A is going to be 0 minus 1. So this is minus 1. We'll have to figure out the adjoint. Now, adjoint, the trick for adjoint is you swap the diagonal elements. When I say swap the diagonal elements, we're going to swap them. Here it's 0, 0. It doesn't make a difference. In some other sense, it will make a difference. Remember, you have to swap the diagonal elements. And you change the sign of the other two elements, the non-diagonal elements. So this is minus 1, minus 1. Remember, we are not swapping the non-diagonal elements. We are only changing the sign. So final answer A inverse is 1 upon determinant A. So 1 upon minus 1 into this same adjoint. When you take the minus 1 inside, the answer, students, will be 0, 1, 1, 0, which indeed matches with A, and therefore it's option B. Further, we'll move to question number 5. They're saying we have a 3 by 3 determinant. The value is 5. Let's call it as A. So determinant of A is 5. We have to find the value of determinant formed by replacing its element by its cofactor. We're talking about determinant of cofactor of A. I hope students, you have done the 6 markers where we find the inverse of a matrix by using minors and cofactors. And I hope you remember this rule that adjoint matrix is cofactor transpose. And therefore, do you understand? Determinant of cofactor is same as determinant of adjoint. Because there is a rule in matrices and determinants that determinant of a matrix A is same as determinant of A transpose. And therefore, determinant of cofactor A is same as determinant of adjoint A. We are using this rule because determinant adjoint A has a direct formula, and that is determinant A raised to n minus 1. So students, I hope you have learned all the properties because these are all property-based questions. Determinant A is 5, so 5 raised to 3 minus 1. The answer is 5 squared, 3, 5. With that, we complete this question. Let's move ahead to question number 6. In question 6, students, you look at the question, it looks that you have to do a lot of stuff. You have to find A inverse, you have to find adjoint, you have to multiply it with A, too much work. This is actually a very simple sum, provided you remember the property for adjoint A into A. Students, adjoint A into A has a direct property. It is determinant A times I. Now, students, for a symmetric matrix of odd order, the determinant is always 0. So in this sum, determinant of A is 0. My sum is done. I'll not worry about A inverse because determinant is 0. Anything into 0 is 0. Answer is simply 0. With that, we complete this question. Let's move to 7. 7th one, students. They're asking D is divisible by which alphabet or variable? P, X, Y. So students, one thing is you can just directly expand it, but I personally don't like that. It's too much work. What I will be doing is, students, I'll be using some properties, some transformations to simplify this. So from the first row, students, I'll take P common. So we get 1, 1, 1. Then we have P plus X. P, this is P, and P plus Y. Now I'll create two zeros, students. I will do C1 minus C2. I'll do C3 minus C2. I'm writing it only for your reference. In exam, you can just do all of this in rough work. You need not write all the steps. This will be 0. This will be minus X. This will be 0. This is 1. This is P plus X. This is P. This is C3 minus C2 is 0. This is minus X. And this is Y. Now, students, because we have two zeros in this first column, I'll expand the determinant along this first column. It becomes easy because I need not worry about the first and the last element because it's 0. Now, this element which we have, students, minus X. Do you understand the term position is 2, 1? It is second row, first column. I hope you know this rule of cofactors. When this 2 plus 1 is 3, it's odd, the sign changes. Minus X becomes plus X. Not that it's going to affect our question because it's an MCQ, but still you should know for the subjectives. And now, students, when we take this element, it belongs to second row, first column. You ignore those elements. You take the determinant of the remaining elements. And that determinant is just Y. So the answer is P, X, Y. Which means it is divisible by all three, students. It's option D. Divisible by P, X, and Y. Next, we'll move to question 8. Question 8, students, adjoint A is given to us, determinant A is given to us 4, we have to find the value of x. We have a formula for determinant adjoint A, students, we just discussed it. It is determinant A to the power n minus 1. Now, students, determinant of adjoint A means we have to take determinant of this. We'll take the determinant of this, so it's going to be 2 into, find to 4 is 20 minus 3, so that's 17. I expect you all to know determinant, so I'm doing it a little quicker. This is minus 3, x into 4 is 4x, minus 1 into 3. You can do this on your own, students. Don't worry if you're not getting it, I'm sure you know how to expand it. And this is 3x minus 15. Once you expand, you'll get this. On the other side, determinant A raised to n minus 1 is 4 raised to 3 minus 1. So students, this is 34 minus 12x plus 9 plus 15x minus 75 is equal to 4 square, which is 16. So students, we get 3x, 34, and then 9 is 43. 43 minus 75 students. 5 students is minus 32, which is equal to 16. So 3x is equal to 48, and we get x is 16. So that is the answer. Let's move on. The next, students, is question number 30. It's actually very much similar to one of the previous questions where we had the compact form. But this time, it's a 3 by 3 matrix. In this 3 by 3 matrix, students, the elements are A11, this is A22, this is A33. And all these other elements, students, will have I not equal to j. I'm not writing it, it's too much work. Over here, when I is equal to j, so the diagonal elements are those elements where I is equal to j, the elements are 1, 1, 1, other elements are 0. So I'll write 0 everywhere else. So students, this is my matrix, which is actually the identity matrix. We are saying a matrix, this matrix A is an upper triangular matrix. Upper triangular matrix, students, I hope you know this theory. It is that matrix where the lower triangle has all elements 0. This is true in this case. So this is true. The determinant of this is 1. You can check the determinant if you want. I hope you already know that determinant of identity matrix is 1. This is also true. So both the statements are correct. Option C is correct. Next, we'll move to question 37. Question 37, students, is again a direct rule. Here, A is a diagonal matrix. Diagonal matrix is that matrix where the diagonal elements are some numbers. Here they've given D1, D2, D3, and the other elements are 0. For inverse of diagonal matrix, students, the rule is very simple. It's also going to be a diagonal matrix. And in fact, we'll be taking a reciprocal of all the diagonal elements. This basically means if we have a diagonal matrix with elements 1, 2, 3, this is 0, 0, 0, all the non-diagonal elements are 0. In this case, the A inverse is going to be 1 by 1, which is 1, reciprocal of 2 is half, reciprocal of 3 is 1 by 3, and 0, 0, 0. I hope you already know this rule. If you don't, you can note it down. So here, assertion is true, reason is true, and the reason is the correct explanation for the assertion, and therefore, we'll say it's option A. Next, students, will move to 47. In 47, students, they have made up a story which is just for formality. The main focus, the main question starts from here. You can read the other parts if you want to. It's not really going to matter that much. So over here, students, they are saying that 1, 2, and 3, 6 is the coordinates of two vertices of one of the smaller triangles. So basically, let's say one of the smaller triangles is this triangle. The coordinates are given, students. Two of them are given. This is 1, 2, the other is 3, 6, and this is missing, students. I'll call it as x, y. Then we have to find the equation of line on which the third vertex of the triangle will lie. So in this case, students will have to solve this with the formula for area of triangle. Area of triangle formula is half of determinant of x, y, 1, 2, 3, 6, and 1, 1, 1. And this is going to be equal to, the area is given, students, is 5. So here I'll take plus minus 5. I hope you know this rule that area can't be negative, but determinant can be negative. So area will be 5 when determinant is either 5 or minus 5. So in this case, students will now solve this by using the basic rules. You expand this. This is x into 2 minus 6. This is minus y into 1 minus 3. This is 1 into 6 minus 6. And that is equal to plus minus 10. So now, students, you solve this. It is minus 4x. This is plus 2y. And that is equal to plus minus 10. There are two possibilities. You take one with plus 10. You take other with minus 10. You'll get two equations. And that will be your answer. With that, we complete the sum. Let's proceed to question number 54. 54 is very straightforward, students. They are saying it's a symmetric matrix. Sorry, it's a skew symmetric matrix. So students, the diagonal elements all have to be 0. If they are 0, A is 0, x is minus 1, y is 3. In the non-diagonal element, students, this 2C, do you understand, has to be minus 6 because this is 6. So C is minus 3. I hope everyone knows what is a skew symmetric matrix. B and minus 1, so B will be plus 1. And 8 and minus 8 are already there. It doesn't make a difference. You take all these values, you substitute, you get the answer. You can complete this, students. The last question that we have is question 125. Here, they are saying Rajesh wants to purchase some fruits from the fruit market. We have been given some numbers and their cost, and we have to simply form the equations and then solve. This is a very basic question where you get the 3 equations and you solve them with the matrix method. So your students, I'll form the equations. For the first case, they are saying 4 kg apple, 3 kg grapes, 2 kg oranges. Let's say that the cost per kg is rupees XYZ. So we'll get 4x plus 3y plus 2z is equal to 600, equation 1. Second equation is 2x plus 4y plus 6z is equal to 900. You can divide by 2 if you want. And then we have 6x plus 2y plus 3z equal to 7. This is given, students. I hope you know how to solve these 6 markers. If you don't know how to solve by matrix method, my prayers will always be with you, students. You need to know this. It comes every year. It will come this year also. And it's a very scoring, the easiest 6 marker that comes. Be prepared for this. So students, with that, we complete matrices and determinants. In the next session, I'll see you for derivatives and continuity and differentiability. Thank you.